volume below that surface down to the ground. So look at what our region is down here. It's a circle, right? But it's not explicitly given to us. We're just given a ball, told how the radius of this ball, and we're told the diameter of the drill bit. Nobody is telling us, oh, this is X is between this, Y is between that. So later we might have to extract the domain from the problem. All right, so what about double integrals over general regions? So we're now going to look at the same concept, but this time the region is no longer a rectangle. So that's what we've done already. A to B, C to D, everything was beautiful. We know how to do those. We now investigate two more types of regions. The first one is what we're going to call a type 1 region. Now when it comes to type 1, instead of calling it capital R for rectangle, we're going to call it D for domain. All right? And the way we're writing this is that the domain is all the points X and Y. So every point X and Y, such that your X is bounded between what?
A and B.
Two constants, right? So it's almost like a rectangle because of our X is between two constants. But look at our Y. What's our Y between? G1 of X and G2 of X. Two functions of X is what bounds our Y. So here's what this looks like. Our X's are bound between two constants, and our Y's are bound between two functions of X. But remember, this is the domain. This is the part that's on the ground that's getting plugged into the function. So we have a G2, which is the one on top, G2 of X, and then a G1 of X. That is what we call a type 1 region. Any questions as to visually what it is? Okay, if our function is continuous and we are looking on a type 1 region, then the double integral over D of the surface with respect to this area is now this. Now, not a lot has changed, but something has changed. What has changed?
One of the bounds.
Yeah, look at our limits of integration are no longer constants, are they? Right? They're functions of X. So this is not going to be like 0 pi anymore. This is going to be a function here and a function here. And they'll both be functions of X. Also notice that the dx and the constants are on the outside, right? You are not allowed to switch these. You cannot flip this and flip that. The functions, right? The variable that depends on X, okay? Y is a function of X here. That has to be the inner integral. And the outer integral, you do the constants. That okay? We'll do an example. But we have one more thing. If we have that same domain, okay? Same domain, type 1 region, and we're trying to find the volume between two surfaces, then everything falls just the same. So look at that surface, see if this makes sense to you. Look at our domain on the ground. Our x's are between a and b. Our y values are between two functions of x. And then we have a bottom surface and a top surface. We're trying to find the volume between the two. Does that make sense compared to the other one? Like this previous one, no, I didn't do it, never mind. That's it, that's the only thing we have. So this is the formula right here. You just subtract the two. I think we need to just do an example, all right? I think that's the best thing we can do right now. All right, find the volume under z equals x plus 2y. What is z equals x plus 2y? Like visually, what is that? I don't see any squared variables anywhere.
Just a surface plane.
It's just a plane. That's just a plane, right? Couldn't we move everything to one side on this? And you would have like x's, y's, and z's all linear equals a constant, and that would be a plane. So we're trying to find the volume under this plane on the region bounded by these two curves. Look at those curves. Y equals 2x squared and y equals 1 plus x squared. So do y'all understand we have a plane? But then on the ground, we've got these two curves. And we're trying to find, if you take the region between those two curves and push it up into the plane, what's the volume underneath it? So what do you think I should start with here? Where should I start?
Find where they equal each other.
Why don't we draw a picture of the domain? Why don't we try and draw a picture of the domain? Just so we see like what's happening here. So my domain, and this will be two-dimensional, won't it? Two-dimensional. My domain lives in the xy plane. Is these two curves. So y equals 2x looks like a parabola that opens up. It's kind of steep because it's 2x. 2x squared, I'm sorry. And then what's the other parabola look like?
It's just a regular parabola?
Yep, it's just a parabola shifted up one, but it's going to be wider than that one, isn't it?
Yeah.
Because it's x squared, not 2x squared. So if I do that parabola, I move up one, it's going to be a little wider, so it's going to go like that, isn't it?
It's pretty wide.
Right. So y equals 1 plus x squared. This is, do y'all see the region? Do y'all see the region we're trying to integrate over? It's the region bounded by these two. So we're talking about this region right here. This is capital R. That's definitely, no, why did I put a capital R? What did I mean to put? D, right? This is our D. This is our domain. Trying to reserve R for rectangles. Although you could say region if you want. That's our D, right? What we're trying to do is we're trying to find the double integral over that region D of the surface, right? dA. That's what we're trying to do. So this is not a rectangle. Is it a type 1 region or a type 2 region? We haven't talked about type 2, so it's got to be type 1, right?
Type 2.
It's type 1, right? Type 1 means that our x's are bounded between two constants, and our y's are between two functions of x. So we actually need to know, if you're in this little red region, we need to know that point of intersection and that point of intersection so that we can determine our limits on x. So how do we determine those 2 points of intersection?
Set them equal to each other.
Set these two quadratics equal to one another. So the intersection is going to be 2x squared equals 1 plus x squared, which means x squared equals 1, which means x is plus or minus 1. So this is negative 1, and this is positive 1.
A and B are negative 1 and 1.
So we have x lives between negative 1 and 1. So yes, a and b are negative 1 and 1 respectively. Now what about my y? My y is bounded between where and where? Those two curves. But you have to make sure that you get the correct one on top and the correct one on bottom. So the blue one is the upper bound, and the black one is the lower bound. So I'm going to put what here?
Small.
This one right here is going to be 2x squared. And this one will be the 1 plus x squared. Questions? All right. Double integral time. Because this is a type 1 region, the first integral has to be the x. So it has to be the constants. Negative 1 to 1. And then the second integral is going to be what? you can write down, yeah, let's do this. 2x down here, 2x squared, and then 1 plus x squared up here. We'll do it that way. And then what goes in the integrand? Or what is the integrand? What is it that we're integrating?
X plus 2y.
X plus 2y, which is the surface. Right? This right here, I should say it this way. Z is our function of two variables there. And we are integrating, this order of integration is d what? D what?
dy
dy dx. That's because x has to be the outside one. So now we have to do the inner integral. The inner integral. What is the antiderivative of x plus 2y with respect to y?
y squared.
X.
xy plus
xy
2 y.
plus,
What are you getting x plus y squared?
I'm integrating x with respect to y. So x is like a constant,
Yeah.
right? Okay.
xy.
And then plus
2/3 y cubed. Y squared. Y squared.
just y squared.
Yeah,
Just y squared. And we're evaluation, right? Evaluation bar here. Evaluating, and what am I replacing here? I'm replacing y with, on the bottom one is 2x squared, and the top one is 1 plus x squared. And then after I'm done with all that, I'll come and do dx. Yeah, I know, it sucks. You've got to replace your y with some variable expression of x, and
On this one, how come you're evaluating the first integral of between 1 plus x squared and 2x squared instead of the constants?
why am I not doing the constants first?
Yeah, because I thought that the constants are on the outside, like the outside integral. So when you do those,
No, you start from the inside and work out. You always do the inner integral first, and then you do the outer integral.
oh, my bad.
All right. So now equals integral -1 to 1, bracket. I'm going to be plugging in. I'm going to give myself some room. And then plugging in, give myself some room. And after I plug in, I've got to do dx. I might have given myself too much room. Let's see. Integral -1 to 1. Okay, what happens when I, let's plug in. Okay, plug in. Replacing y with 1 plus x squared here and here. So x is 1 plus x squared plus 1 plus x squared squared. And then replace all your y's with 2x squared. So x times 2x squared plus 2x squared squared. Square. Everyone understand what I just did there? All right, let's clean that up. Let's clean it up. Maybe I can just clean it up right under here and I'll put the answer in there. So this, I believe we're going to get x plus x cubed right there. And then plus, and if we FOIL that out or expand it, we should get 1 plus 2x squared plus x to the 4th. And if I put all that together, I should get x to the 4th plus x cubed. Really? Plus 2x squared plus x plus 1. Nothing, no like terms there? No like terms. Okay, well what about over here? What is this? So minus, what do we get in here?
2x cubed.
2x cubed
Plus 4x to the 4th.
plus 4x to the 4th. And then I'm going to subtract those from there, right?
Nothing cancels out all the way.
Nothing completely canceled, but I do get some combination, right?
Yeah.
So how many x to the 4ths do I have? Negative 3x to the 4th minus
Negative x.
just x cubed. plus 2x squared
Plus x plus
plus x plus 1. I'm not even looking. Is everyone okay with that?
1. Yeah.
And you know what? I don't need the brackets. I thought I was going to need them, but we're integrating that with respect to x.
Yeah.
And now you're in Cal 2. You're in the beginning of Cal 2. This basic power rule. This is a pretty straightforward integral, right? Equals dot dot dot, which means I'm not going any further. What do y'all think? Type 1 region?
Not bad yet.
Okay, good.
It's type 2. Instead of having a and b as constants, you have two other functions of y. Or
Type 2, let's see, I think type 2 might be right around the corner here. While we're here, I'll answer your question in a second. I just want to go real quick to Wolfram alpha.
yeah.
Will it do an double integral? Integrate. What was the inner integral?
The integral was x plus 2y.
X plus 2y from lower limits of integration 2x squared to 1 plus x squared with respect to, we did with y, right, first? Look at that, it's like I'm just speaking to it. And it's going to tell me, y upgraded. There we go. So that's what we got, right? Yeah. And now I could just go back up there and I don't think I can copy this. I think I have to pay to have it copied. Oh no, look, I just clicked it and it brought me a new one. Nice. Integrate that from -1 to 1. There we go. 2.1. That didn't take long, right? Technology is pretty awesome. Pretty awesome. I wish we would have had that stuff when I was in school. It would have been nice. Oh, wrong one. Let's just look at this example. We won't work it all out. Let's at least just set up the double integral, all right? Volume underneath z equals x squared plus y squared. So this is our surface. Was there a picture that went with the last one? Yeah, look at that. I went through all that effort to make this. So I may as well show it to you. So that was our domain here on the left. We took that domain and there was our plane. So we plugged it in and then we get this solid region here. We found the volume of that. Excuse again the jagged edges. Remember that's my computer. Just being asked not to hurt itself. So we found the volume of that. This one. The volume under x squared plus y squared. Region bounded by y equals 2x. Y equals 2x is a line. And y equals x squared is a parabola, right? So let's start by drawing that. So my domain, y equals 2x. And y equals x squared. It's that piece right there, right? All right. So do I need to, can you see that it is a type 1 region? If you're having any issues with seeing it's a type 1 region, just think about, this is the way I like to think about type 1, type 2. Or not type 1, type 2, just imagine, if I'm looking at type 1, imagine that I'm drawing little rectangles in here. Okay, like that. if I move the rectangle to the left and to the right, between, let's say, A and B. So imagine that that rectangle slides to the left between A and B. Does the top and bottom of the rectangle always stay between two functions of x? So as I move that rectangle over, is the function of x on top the same? I mean, the one that was on top here and here, are they the same one?
Yeah.
And then down here, it's the same one, right? Doesn't matter where I put that rectangle. The top one is the line, the bottom one is the parabola, no matter where that is. That's a type 1 region. All right? I'll show you an example of something that's not type 1 in a minute. But so because of this, I need to find this point of intersection, don't I? So that I can find B. I can tell what A is, right? Can you tell what A is? A is 0. But we're going to get them, if we set them equal to each other, we're going to get it anyway. We do not divide by x, right? We move everything to one side. I'm tired. This weekend, my wife said, we're going to do a garden. So I've been building a garden. She goes to the store and buys all these plants and then says, I need a garden. So I build a little 4x8 wooden above ground garden for her. Not hard to do, quick and easy, right? Little 4x8 thing. Hardest thing was getting the dirt and bringing it in. So she puts it in, puts her little plants in there, and it comes up to me and says, there's the plants. These are the ones I haven't planted. She had a bunch of them still there. So now we have 3 of these. Okay, so I had to build 3 of them. Right? And she doesn't want the birds getting into them.
See, that's where you just get a divorce.
All right. Okay. All right. So now I'm building an enclosure around this. 20 feet by 10 foot
Oh my gosh.
enclosure that's going to have bird netting around it.
No.
So how's that plastic?
You put it's like the tomato plants, you put something red before they bloom, and then the birds will be like, oh, hit the red place, I'll leave no fruit. And then it'll be
I guess we had a garden a few years ago in our old house, and
Yeah.
we had a great, I guess, crop or whatever, and all the birds got to it. Anyway, look, I don't mind, whatever. But I was up last night at like midnight with my headlamp on, like screwing things in. I'm tired. All right, where was I? X is 0. I'm going to play my wife for being delirious today. X is 0 and 2, right? All right, so what about our functions? What's the top one here? What's the bottom one?
2x.
So 2x is the one on top, and
X squared.
y equals, and then y equals x squared there. My dad told me once about the 3 rings of marriage. Have you heard of the 3 rings of marriage?
The sulfur ring?
Yes, that's what
The
the engagement ring, the wedding ring, and the supper ring. He's
Oh.
kidding. He's kidding. He's kidding. My dad's a jokester. All right. What am I doing? What do I do now?
Now
You have to find the constants?
So-
we already did that.
Yeah, I got the constant. I know x is between 0 and 2.
the double A.
Y is between,
The one on top is the bigger one.
yes, the bigger one's
2x.
2x,
And then x squared.
x squared there.
And then you can put it in.
Yep. All right, so let's just make sure we set it up. We won't carry through the integration. What are the limits on the first integral? 0, 2, and then the second one, x squared, 2x. The integrand, and that's going to be a pretty clean integrand, isn't it? And then d what? dy, and then dx. There you go.
Functions of y.
What functions of y?
What?
Functions of y.
Yes.
That's type 2.
Oh, I called it.
That's type 2,
That
yes.
sucks.
Okay, so I'm going to stop there. Move on.
Yeah. I wish I was wrong.
You wish you were wrong? Type 2 regions. Here's what they look like. So look at the difference between this and a type 1. A type 1, your x's are between two constants, and your y's are between two functions of x. Here, if I try and use that same idea where I draw little rectangles, look at the top and the bottom here are actually the same curve, right? They're not two different functions of x. So we can't do it that way because this one and this one both fail the vertical line test, right? So instead of looking at them as functions of x, we look at them as functions of y. And then we're looking at it like if you give me a y, then I'll give you the x value. Now if we go this way with our rectangles, you can see that the left and the right points right there are always on the same two functions when you go this way, right? Blue one, red one. Blue one, red one. Right, so this is what makes a type 2 a type 2. And the y values are stuck between two constants, C and D, right? So that's what this says here. Your domain are all the points where your y is stuck between two constants. This time your x is stuck between two functions of y, and that means that the integral, when we set it up, is going to look like this. So the order of integration switches, doesn't it? Your y is now on the outside, and now you're going to integrate with respect to x first, and you have two functions of y on the inside.
The order of the integral doesn't change, but dx dy does between type 1 and type 2.
The order of the what?
The integrals, like the c, d, and then the functions are always the second one, right? Because in type 2, it was the functions of x, but it was still the second integral.
Yes. So on both type 1 and type 2, whatever your functions are, whatever your limits or functions are always on the inner integral. Whatever's the constant is always the outer integral. Is that what you're asking?
Hold on.
I'll just put the other one up here.
I hope not. I think I just.
So like the first integral has the constant, the second integral has the function.
Yes.
That's the same for type 1 and type 2. The only difference
Yes.
between the two is dx and dy flip.
Yes, but these functions are going to be different also.
Yeah.
Yes.
Okay.
These are going to be, if dx is on the outside, then your inner integral, the limits of integration are going to be functions of x. If your dy is on the outside, then your inner integral's limits of integration are going to be functions of y. And we just have to do one of these. Find the double integral over the region D of x times y dA on the region bounded by y equals x minus 1 and y squared equals 2x plus 6. So whenever we say we have a function of x, that means we can solve the equation for y. If we say we have a function of y, that means we can solve the equation for x. So if I try and solve this for y, which it already is, then I'm good, right? This is a line. You could look at this as a function of x. Y is a function of x. This one you cannot, because in order to solve for y, you need to take the square root. You would have plus or minus. You would have two different answers. So you can't solve this cleanly for y, right? But you can solve this for x, and you can solve that for x. So why don't I solve this for x? That's x is y plus 1. And if I solve this one for x, let me see, I get 2x equals y squared minus 6. So x equals 1/2 y squared minus 3.
So is that where we figure out if it's type 1 or type 2, is which?
Well, we have to draw is where we find out. We have to draw these and then look at the region and tell what it is. All I'm pointing out right now is that this right here can be looked at as a function of x or y, because you can solve for y or you can solve for x. This one, you can't solve for y, you can solve for x, so it's looking like this is going to be type 2. We just need to verify with a picture, all right? All right, now, in terms of drawing these, to draw this one, I'm actually going to go back up here and just use what I already know about lines. This has a y-intercept of -1 and a slope of 1. So that goes like this. Okay, that one is, this is y equals x minus 1. Now, how are you going to draw this one? It would help if you kind of knew what it looked like. Like, do you know what that looks like? Do you know what this looks like, or what this looks like?
Wouldn't it be just
It's
like
open to the
a wider parabola shifted down?
It's a parabola, but which way is it opening?
Opening to the right.
It's opening to the right,
Oh.
because the squared is on y, not on x. If the squared is on x, it goes up or down. If it's on y, it goes left and right. So the way you can look at this is, I mean, well,
You can just like turn the graph.
yeah, it's kind of like if you were asked to graph this, right? This would be a parabola, half would make it like this, and then down 3, right? But because it's the other way around, we are going to have it go like this, kind of widened up, and then backed up 3, like this way. Just trying to get a feel for what's happening here. I don't know where they hit each other. I'm just, that's the general picture that I have. So this one, I'm going to write it down. This one was the y squared equals 2x plus 6. Now, do you see the region bounded by the 2?
Yep.
All right. The question now is whether or not it's type 1 or type 2. So is this region type 1 or type 2? Let's try type 1. If I draw a little rectangle right here, the parabola is on the top and the line is on the bottom, right? And if I draw a rectangle here, same thing. Is that always going to be the case?
No.
No, because when I get over here, now I've got the parabola on the top and bottom, right? So this is not going to work as a type 1. As a type 2, though, it does work, doesn't it?
Yep.
Because as a type 2, if I draw my rectangle this way, it's always parabola on the left, line on the right. Parabola on the left, line on the right. Parabola on the left, line on the right, no matter where I am. Now, you don't want to have to sit here and draw these. You just want to be able to look at it at some point and just know. But do you all see that? Okay, so this is type 2. As soon as I know it's type 2, I need to switch these, solve for x. Right, so these right here are my two functions of what?
Of y.
They're functions of y, right? X is a function of y. So like if you're looking back at your notes, this is like, was it G or H? H, right? This is like H1 of y, H2 of y. If you look back at the formula. See that? H1 of y, H2 of y. So at this point, right now, I can actually write something down. I can say, I have restrictions on x and y, right? Can you tell me what I have restrictions on that you know for sure right now just by what I have written here?
This is less than or equal to,
Which one? We're talking about the x's or the y's?
x is
Okay, the x has got to be,
less than or equal to 1/2 y squared minus 3.
so this
That's greater
1/2
than-
y
no,
squared,
it's
where do you want
greater.
this one?
Yes, that one is less than or equal to x.
So that one's over
Yes.
here, yes. 1/2 y squared minus 3. And then the x has to be smaller than y plus 1. So you know how with type 1, it's, the one on top is bigger than the one on the bottom? But in type 2, the one on the right is bigger than the one on the left. So it's like positive numbers, negative numbers, so these are bigger than that. So bigger, smaller. Our x values, see, all our little x's, we move from left to right. Our x's are all trapped between these two. Now what about our y's? We have to figure out these intersection points, right? We need to figure out what D is, and we need to figure out what C is. So set them equal to one another. And when you do that, set these two equal to one another. Because we want to solve for y, don't we? And if we set that equal to that, we'll have an equation with y. So intersection y plus 1 equals 1/2 y squared minus 3. Had you heard that suffering before?
Yes.
Okay, you'd heard of it.
I have.
I wondered if you had. I just wondered if you had come up with that on your own or something. Because no one has ever replied to me who knew what I was talking about. That's kind of weird.
I think I've heard it before.
Yeah. This is a quadratic, isn't it? Let's just bring everything over to one side. Yeah. I don't care for fractions. Just multiply everything by 2 just to get rid of the fractions. And then I'll factor. So we have two solutions, 4 and negative 2. So I know my y now is between negative 2 and 4. And that's it. I have everything I need to set up the integral. That's going to be a perfect ending here. We'll set it up and let you play with it. On your exams, on a lot of these problems, anything that you see on the final, most of the problems on the final are going to be set them up but don't evaluate them.
Really?
Yeah, because it's just too much time to go through all the problems and take them all the way to the decimal answers. The setup is the most important thing. Because once you get it set up, you can go to a computer, right? It's the setup that the computer can't do. Yes.
So, for the setup, you just need to get it up to the point where we have our,
Right here.
oh, just that, we
Right
don't
here.
really.
Yes, let's get this.
Right, so,
Well, I'm talking about like on the final. Take no many exams, you'll have to work them the whole way. Your homework, you have to work them the whole way. But final exam, if I gave a final, you would only be able to do like maybe 4 of these, you know? I want you to do 20 setups as opposed to 4 computations. Not 20 of these. We have a long way to go. We have 2 chapters. So, all right, what's on the outside integral here?
Negative 2.
Negative 2 to 4. And then half y squared minus 3 to y plus 1 on top. We're integrating x times y, d
X dy.
dx dy. There you go. Yes?
So it's the left boundary to the right boundary? On the double?
So left, are you referring to these guys?
Yes, I am.
Yes, left to right, left to right. All right, and that would be it. From there, you integrate with respect to x first, and then you replace x with these two, and then you integrate again, then replace your y's with 4, negative 2, and subtract and all that good stuff. Okay, that's it. We are still working in this section. I believe there's more. Yeah. Yeah. But that's it for us today. So have a good weekend.